Shown in this slide is the general architecture of an AC induction motor. The rotor revolves within the stator, a fixed electromagnet housed inside a metal frame. A drive shaft supported by bearings is fixed to the rotor, supplying torque and speed to an external mechanism. A cooling fan conducts heat from the stator coil magnets out the rear of the motor. The conduit box holds the electric wires from the line power and distributes them to the windings. The stator consists of a series of flat steel discs laminated together. They're aligned directionally to form channels for the stator windings. These windings consist of layers of copper wire, which when passed through the channels create loops to form an electromagnet. The pattern of coil windings in the stator determines the number of poles for the motor, an even number usually between 2 and 12. The rotor channels consist of solid bars of copper or aluminum. These bars are connected to rings at the front and back of the rotor, which creates a continuous high current conducting loop. In smaller motors, the bars and end rings are cast as a solid steel cylinder known as a squirrel cage. Aluminum or copper conductors are embedded in the surface of the cylinder. The rotor is inserted in the stator with an air gap of roughly 20,000ths of an inch, which is half a millimeter. Any more of an air gap will significantly reduce the ability of the stator to induce current flow in the rotor. Let's go over some basic electromagnetic principles. Oh no, please, no. Oh. Did you guys study electromagnetic principles in freshman physics? Why do you think your school forced you to learn it? Because they knew that someday, maybe in the distant future, you were going to study actuators in a Coursera class. Of course, Coursera didn't even exist before the year 2012. In the old days, professors like me looked out on a vast gallery of comatose students when we lectured, and that's if they showed up at all. Now, we get to stare right into that camera, only imagining what our students think of us. But on second hand, it's probably better for us not to know what's going out there on the web. Okay, where was I? Yes. Recall that when an iron rod is suspended freely in a magnetic field, it will align itself with the field. If that field is rotating, the iron rod will rotate with the field, so as to maintain alignment with it. You can create a rotating magnetic field from fixed stator poles by driving each pole pair from a different phase of the alternating current supply. With three-phase AC power, you create a three-phase AC motor. The stator windings induce current in the rotor windings, avoiding the need for a direct electrical connection from the power source to the rotor. Let's go through how torque is applied to the rotor. The stator carries the primary windings, and its windings are directly connected to the power source. The three field windings are out of phase by 120 degrees with each other. As current applied to pole pair A, in other words, phase 1, passes its peak and begins to fall, the magnetic flux induced in winding A weakens. Current in the winding of pole pair B, in other words, phase 2, rises along with its induced magnetic flux. Current through the winding of pole pair C, in other words, phase 3, is negative, but it is tending positive along with its magnetic flux. As a result, a magnetic flux wave is set up. The flux created by the stator poles rotates from one pole to the next. The flux wave appears to the stator as the north and south poles of a magnet rotating around the stator. The magnitude of the rotating flux wave is proportional to the applied voltage. There are no external connections to the rotor, which carries the secondary windings. The three-phase AC power inputs are connected directly to the stator pole pairs. All three phases of the AC power input have the same amplitude and frequency. They differ only in being 120 degrees out of phase with each other. The rotor windings are shorted together, a large electrical conductor rotating within a magnetic field. The AC induction motor gets its name by the fact that current is induced in the rotor windings by the magnetic field rotating around the stator. Torque is induced in the rotor by the reaction between the induced rotor current and the rotating magnetic flux. Recall what I said a half a dozen slides ago. If an iron rod is suspended freely in a magnetic field, it will align itself with the field. If that field is rotating, the iron will rotate with the field. In an AC induction motor, the rotor is analogous to the iron rod. Recap. Now you know how a three-phase AC induction motor works. In the next video, we will define the various specifications of that motor so you will know how to shop for one.